It's called the catapult. I don't know. She didn't really specify if we couldn't do a trebuchet.
Okay.
We're not there yet.
Trebuchet would be fun.
On your desk, I want you to try to find the derivative of this thing I'm going to write up on the board.
Just find derivatives?
We're going to find the derivative.
It's going to be like 3 letters, and you're going to be like, oh god, how do I do this?
Yeah. I don't
So
like,
we're going to try to find the derivative.
First
I don't like when there's more than 2 variables.
X.
Same.
Okay, what I want you to do is do not multiply them together and find the derivative first. What I want you to do is figure out how you think you could find the derivative of these.
What?
Okay. 2 things multiplied together. Many of you did this on your quiz and found that it wasn't right.
So are we supposed to do this? I'm confused now.
Do it how you think you would do it if I gave you this.
Maybe.
Maybe.
I guess.
Can you just leave it?
I hope.
I thought you
Probably
just-
not though.
So you took the derivative of each and multiply them together?
Oh, I
Okay.
thought you just leave them.
You're just leaving them after you did them? Okay, well, okay, so now multiply these 2 together and see what what happens? Okay, so you found it, this is the right way, we know that this is the right way. Now the question is the way that I told him to do it, does it come out with the same answer?
No.
Okay, so yeah, this is, we know how to do this with the power rule, right?
This marker really bothers my feet on this desk.
We know how to do this with the power rule, we would say this is just really x to the 5th, and then we would find that that's 5x to the 4th, the derivative, let's say y prime equals this. We know that, right?
I thought you were right.
I'm gonna go with it too.
Yeah.
Me either.
I'm trying to make your brain stretch a little. Okay, so we know that this is the right answer because of the power rule.
I'm not gonna lie.
I didn't get that.
You didn't get that. So my question, yes, because I told you to do it a different way, right? I told you to try a different way.
Lord.
Yeah, that's
So-
why I did it this way,
Oh
because you
my
told us to
God.
do it the other way.
So my question
I have a
is,
new marker.
for those, don't worry, it'll wipe off, I promise. I just have to do the Clorox wipes.
This like hurts my feet, but I don't like the sound of stuff on the desk.
Oh,
I don't
you
know why.
don't?
Mm-mm.
I'm sorry. Okay, so my question is,
The squeaking's not bad. It's when it's like not squeaking. I don't know.
my question is,
It's weird.
does this equal this, right? Remember when we did terms, we add them together, we take the derivative of each term,
With the
right? So I told you to try it this way, and this is what you got, right? Carter, you got 2x times 3x squared,
Yeah.
right? So we took the derivative of this, we multiplied it by the derivative of this, and that gives us 6x to the 3rd.
That's wrong.
But we know for a fact that the derivative of this one is 5x to the 4th. We absolutely know that. So can I, if I have 2 things multiplied together, can I just take the derivative of each of them and multiply it together?
No.
Nope. Because remember, the way you prove something is if it has one false instance, then it's always false, right? So it doesn't work for this one, therefore it never works for anyone.
My
So
feet hurt.
now that I've confused you sufficiently, the question is, what do we do when we have 2 things multiplied together?
Multiply them together.
Well, we could. We could multiply them together.
Carter's vandalizing all the desks.
That's okay. I kind of condone the vandalizing of this.
I.
So in that case, you could multiply them together. But there are times when you can't multiply them together because we have things
So never multiply them together.
like we want to find the derivative of like,
I hate that, dude.
I want to find this. This is the derivative of
Oh.
sine times cosine. You don't know how to do this, and that's okay.
Sine cosine x squared. No,
Yes. Oh yeah.
Oh.
Guess what? It's super
Sine
easy.
cosine x.
Derivative of sine is cosine, and derivative of cosine is negative sine. It's super easy, but I'll tell you. But here's the thing. We cannot, right now, we can't just multiply cosine and sine together and then do a power rule on it, can we? We don't know how to do that. So we have to have some kind of a rule. We have to have some kind of a rule to help us figure out how to find when we have the product of 2 different relations. So two different things in terms of x, okay? So if I had something like x minus 3 times x plus, I could do it even bigger than that. I could do like,
Can I have a whiteboard?
yeah, x squared plus 3x plus
You have to foil
15.
before you do
So like, the only way we know right now to do this is to multiply this whole business out and then take each term individually, right? But we're gonna learn something today called the product rule that we can use to do it when we have two things multiplied together, two things in terms of x, okay? So I have a foldable. I have a foldable we're gonna make. So, I didn't hit
Foldable.
them staple
Oh
yet.
no.
So you
Why?
get to
Dude, this tripped me out for a second. I didn't know there was magnets in these.
Okay, take
I'm
one
like,
of each.
What?
It says magnetic whiteboard eraser on it.
That would
He's a
be,
teenager. You think he read?
that would
Yeah.
be, John,
I
you're
would.
the only person that reads.
Dude, I can't even
Okay.
read it. It's covered in
One
marker.
of each. One of
You're
each.
not wrong.
We're gonna make
Wait.
a foldable.
That was so anticlimactic.
Wait.
If it worked, that would have been.
Yeah. You ready, Levi?
Okay, you take one of each.
Easy,
Still not epic.
Here you go, Alex.
Okay. Take one of each. And then you're gonna take this awesome stapler. And I'll show you how to do it. Okay, wait. So,
I think I
stack it so
figured
the
it out.
derivative rule. And then, see product rule right here? You push the product rule up.
Did I get it?
Derivative is on top. Oh, what? What?
Did I get it?
Yes.
Oh, okay, okay.
Yeah, like that. So you push it, so you have the derivative rules facing away from you, and then you push it so product rule is kind of like pushing up on it. And then,
I'm gonna fold it in.
thank you.
So then you see all four of them.
Then you see all four of them like this,
No, no.
So
and then you take that fancy stapler and you staple here and here. So you open it up and you set it on like this, and then you can staple.
what? I got confused.
Okay, so face derivative,
So they make
yes,
books.
you have it, and now you just fold it down. There you go.
Yeah.
Okay, so these are some of our derivative rules that we're gonna use. There's lots of derivative rules.
We shot
These are our
over
main
here.
ones.
Really?
Yes, I saw it.
I didn't know what it was.
Right?
What?
It's taped together.
So the first one we're gonna talk about today is the product rule.
We're gonna go weld it back together.
I need to, what happened to my phone?
Press shot it with the staple.
False.
Oh boy. Gotta push a little harder than that.
Tanner and Briley.
These from last year?
All of the, well, that's, people wrote on them from last year.
Yeah.
I had to
This is
cover up
Tanner,
a few of
Harold,
them
and
because they
Briley
were,
when they were
had
dating.
Ooh.
slurs and things. Okay,
Why won't you just?
Cause you got an easier get out that way than I do.
sure.
You need to
turn
get
me
it
all
in
the work.
shape.
What does that mean?
Is that a fat joke?
What'd you
What?
say?
No, I'm just saying you gotta get it in shape.
Oh, ouch. You never ever say that to a woman, like,
Yeah.
ever. Okay. Inside, where it says product rule, look at John being such a gentleman going and getting the stapler for himself.
Yeah.
Hey, see, John should, because he can get out easier than Alex can that direction. That's the way it works.
Okay.
If I had to go get this, I'd go that way.
Yeah, get it from me.
Okay. Inside on the product rule, so you open it up and it's your first flap.
Wait, oh.
It'd be like here, right?
I don't
So
know why I
you
gave
see
this.
product rule. You're gonna see product rule when you open it up.
Gotcha.
You're going to write this. d dx of f of x times g of x. So the derivative of two functions multiplied together equals f prime of x, g of x, plus g prime of x f of x. So there's a couple different ways that we're going to remember this. I'll let you write it down here for just a sec. Stable mine while you're writing.
Don't even know all.
Okay.
Even know all, don't you?
So this is how we remember the product rule. This is how we remember the product rule. Fig plus gif. Do you see that?
Ah.
See, the prime is kind of like an I, so it's fig plus gif. Okay? So the product rule, and you could write that on your, you could
Fig
write
plus
that on
gif.
your fig plus gif. That's one way. Okay? So if you look at this, what we said is if I have two functions multiplied together, the derivative of that is the derivative of one times the other plus the derivative of the one times the other, right? So here's the other way you can remember it.
A lot more work.
That's
Do.
Okay, this is how you can remember the product rule. The product rule is do-do. The derivative of one times the other plus the derivative of one times the other.
Big gift.
So it doesn't really matter, however, which way you think of it.
Big gift would probably work better.
Big gift is probably easier. But someday you might think the product rule is do-do, I hate you. Okay, so let's look at how this actually works, looks. So in your notes, you can grab your books, and we have a couple of examples. Oh, I have it up here. All right, so here's a function, and it's defined as two different functions multiplied together. Do you agree with me there? You see that?
Yeah.
This is two different functions multiplied together. So we could call this one f of x, and we could call this one g of x, because there's two different, we probably shouldn't call that, I don't know. I'm going to rename this one, like, capital F.
Just do like H.
So it's
Yeah.
like the big F of X.
Yeah, this one, let's call this one h of x, because that's, okay, because,
Yeah.
so this is our f of x, this is our g of x, and we multiply them together, we get a new function.
They
And
could
we're trying to
just be
find,
nice and multiply it for us.
you could multiply that out if you wanted to,
They could just be nice and do it for us.
they could. But remember, a lot of us get stuck in algebra sometimes accidentally, we do the calculus right and the algebra wrong. So in some of these instances, you totally can, and if, with this one, if you wanted to FOIL it out, you totally can, and we could check to see if our answer is right with FOIL. But let's do it with the product rule first and see. Okay, so this is what I want you to do. I'm going to write it really nice and big here. So this is f of x. This is g of x. Oh gosh.
Big gift.
We're going to do fig gif. So I want you to draw like a little thing like that. And we're going to do the derivatives down here. So we're going to do f prime of x down here and g prime of x right underneath each other. Okay, so we're going to find f prime of x, which is 6x, just 6x. And then this one is just 2. Okay, so when you set it up like this, then we can just do fig gif, right? So we go fig gif. I did the wrong way, but gif, there we go. Right, so I go multiply this times this.
Multiply
Yep, so we're going to multiply, because remember it's
adding.
No, we add the two.
fig plus gif. So we multiply f prime times g. So 6x times 2x plus 3. So this is fig plus gif, which is 2 times 3x squared minus 2. And then we just do the algebra, because If this were on a free response, you could just leave it like this, but more often than not, something like this is going to be on multiple choice, and so your answer is not going to look like this. You do need to know how to do your algebra, so let's do that. So we have 12x squared plus 18x plus 6x squared minus 4. So we have 18x squared plus 18x minus 4. So the derivative of this h of x up here, the derivative of this entire thing, is this. Do you guys want to check it with FOIL?
That's why we did all that.
We already derived in our little chart. We already derived. Let's check this with FOIL. 3x squared minus 2 times 2x plus 3. So we're going to FOIL the whole thing out. We get 6x cubed plus 9x squared minus 4x minus 6. Did I do it all right?
I think so, yeah.
Okay, and then we get 18x squared plus 18x minus 4. See how we got the same thing? Now, it's your choice, unless I specifically ask you one way or the other. If I say use the product rule, I want you to use the product rule. But if algebra is easier, do algebra. If product rule is easier, do product rule. Just understand there are a number, many times when you will not be able to use algebra. You will have to use the product rule. So if you don't do the product rule, I would practice it. All right, you guys ready for the quotient rule?
No.
Is it the same thing but divide?
No, I wish it was.
That'd make it so much easier. Of course, find out how to do it.
Okay. The quotient rule. I'll tell you my little mnemonic first. Okay, so if you have the derivative of f of x over g of x, and we want to find that, this equals, this is my mnemonic, and then we'll see what that looks like, low d high minus high d low square the bottom, and away we go. So low d high minus high d low square the bottom, and away we go. Yay! Isn't that beautiful?
Sounds like Chinese.
I have all sorts of, there were some product rule songs that I thought about teaching you.
Low D high.
Yeah, it's pretty good. There's some like,
Is that like low derivative?
so when I say, so now let's figure out what this actually means. Low means the bottom function.
So g of x.
High
times
means the top function.
Derivative of a.
So yeah, so exactly. So we're gonna say g of x d high, which is f prime, minus high d low square the bottom, and away we go. But here's what you might recognize. It's fig minus gif. Did you see that? Fig minus gif over g squared.
What? Low D high minus high D low.
Because really, this is the same. G times f prime is the same as f prime times g.
Yeah.
So this is really fig. This is really gif. And the only thing we added, we subtracted instead of adding, and then we added that squaring at the bottom. That's really important. That's going to be forgotten. So that's why I low d high minus high d low, square the bottom, and away we go. So should we look at how that looks?
Don't want it to break my brain.
I know. Okay.
It's going to though.
So y equals 2x squared minus 4x plus 3 all over 2 minus 3x. Okay? This is a quotient. And if you were crazy, you would could go and divide all of that with algebra and then just do the power rule. But that would take like synthetic division and all sorts of other nasty stuff that is so much harder than this. So let's figure this out. We have f of x, g of x. Let's figure out what they're... Okay, f of x is our top one, right? So 2x squared minus 4x plus 3. Our g of x is 2 minus 3x. So
I hate it when they put the 2 before the x. Like the whole number. No, like.
It is annoying, isn't it, right?
Yeah. But I mean, it doesn't do anything, but it's just annoying.
It is annoying. I rewrite it a lot, so rewrite it if you want. Then it makes you...
That's more work.
Okay, we differentiate this. 4x minus 4.
Yep.
And this one is negative 3. Okay. So now we do low d high minus high d low, square the bottom, and away we go. Basically, we go fig, which is 4x minus 4 times negative 3x plus 2, low d high, minus gif, and then here's the one you have to remember is we square the bottom. We square g squared, or g. So then it's just a ridiculous amount of algebra.
Good.
Blech. So, you guys remember FOIL? Did you ever do the box method? Like this, so if I had 4x minus 4 and negative 3x plus 2.
Yeah.
So sometimes this just helps me organize my thoughts because FOIL, I sometimes get lost in which ones I'm doing. So I know it seems a little elementary, but this is actually, it's FOIL just in a different way. So then you'd have negative 12x squared plus 12x, 8x, and negative 8. You see I just multiplied each thing. This one works really, really, really nicely when you have 3 and 4 terms, when you're trying to multiply like a binomial by a trinomial. It is like the best because you just put them all up in here and then you just multiply everything in the boxes. So this first one is going to be negative 12x squared plus 20x minus 8. That's this thing, right? Then this one we don't really even need FOIL or anything. We just need to multiply everything by negative 3. And actually this takes care of that. So we just multiply everything by positive 3. So we add 6x squared minus 12x plus 9. Okay. You with me so far? Feel good about this? Okay. And then we just do g squared on the bottom, which again is negative 3x and 2. So we do 9x squared minus 6x minus 6x plus 4. And then we combine some like terms and call it good. So let's see, our x squareds come together, so we have negative 6x squared. Our x's come together, so we have 8x plus 1. And unless you had to go further and do some factoring or something like that, then that would be sufficient. Honestly, again, on a free response, this is sufficient on a free response.
What is a free response?
So remember, okay, so on your test, I have multiple choice, and then I have ones that you have to fill in. That's a free response. On the AP test, they're usually a little more advanced. They're just like, they take in 3 or 4 concepts, and they have like 3 or 4 bullet points. But basically, anything where it's not multiple choice is considered free response. And we'll practice some more like AP style ones later as we get enough information to actually do them. Okay. Quotient rule, how does it feel? Easy? Should we do one more? Let's do one more. Okay. Quotient rule. This has 90. Oh wait, it's a quotient, but do I need to use the quotient rule here?
No.
Because is negative 9 a function? What's negative 9? It's a constant, right? It's just a constant. So you could do the whole business, but I'll show you what that looks like. So we have f of x. If f of x was 9, this is why when we multiply it by a constant, it doesn't matter. Because the derivative of 9 is 0, and so then this would be 10x. So if I did fig, it gets rid of that, right? And basically all I do is gif, so I multiply the constant by the derivative of the function. That should be. So really, remember how the constant rule tells us we just take the constant, we multiply it by the derivative of the function? It's the product rule at work. Does that make sense? That's like a quick and dirty proof of why we just multiply by the constant. Yeah?
Why?
Okay.
So what's the answer on this one?
So what's the answer on this one? Well, this is a constant times a function. This is really negative 9 times 5x to the negative 2. I mean, not 5x, sorry. That's 1/5. Right? Because that is 1/5 x to the negative 2. This is what happens when I do quick and dirty proofs. Okay, there we go. So that's really just that.
Yeah.
We know when we multiply a function by a constant, we just take the constant out and then multiply by y prime, right? So all I have to do is find the derivative of this, multiplied by negative 9. So what's the derivative of this?
1 over 25 negative 1.
Well, the 5 isn't squared, just the x is squared.
Oh.
So it would be, I bring the negative 2 down. So then I multiply this whole thing by 9, right? Because this is y prime. So I have positive 18 over 5 x to the negative 3. That's the derivative of that one. No? You look like you have no idea where that came from.
I know how you did it, but I don't think I can do it.
Okay.
I know exactly what you're saying.
Okay, then do this one. Y equals negative 5 over 3x cubed. Let's find the derivative of this function, okay? So you can do that in your book, you can do it on your table, except for Levi, who hates
Oh,
the sound
heck
of it.
yeah, I'm doing it on the desk.
There is a whiteboard underneath most of your desks, if that makes you less
Does it
cringy.
turn off of these better?
Yeah, it really does. I want to get, like, there's whiteboard vinyl that you can just put on the desks, so then they're all whiteboards, and that would be better. The desks clean off with Clorox wipes, I don't mind. Okay, so think about this, write it as the product.
It would be good just to do the whole product rule so I don't keep confused.
You think so?
Yeah, because I don't understand why you would do it the other way. Where do you get y prime by?
Which part? Which part is like?
So you wrote it as that.
Oh, yeah. Okay,
Y.
well, so that's, remember that's like when you multiply by a constant?
Zero.
The derivative of a constant is 0. But remember when I have a function multiplied by a constant, so the derivative of 5x squared. Okay, I take the derivative of x squared, right, and I just multiply it by 5. Do you remember that part? So that's like the constant multiplication rule or something like that of derivatives. So basically, if I have a constant times a function, I take the derivative of the function, and then I just multiply it at the end by the constant. But what I was trying to show is that it really just comes from the product rule. The product rule tells us that, so you could do the whole product rule and you would get one of your terms would become 0. But oh, maybe it simplifies some of that. I don't know. I made it up on the fly, so I'm not sure. If I could get it.
So I needed help on a couple of these. one, I was confused because it, like,
Did you get it?
your vertex is at -3, 6, but there's no 6 on here.
So it would be a
I
negative
got
3, 5.
I don't think I did it right.
But don't you plug in your -3 and then your other value is your y value?
You could, but if you plugged in negative 3 to this, negative 3 plus negative 3, or plus positive 3 would be 0. 0 squared is 0 times negative 2 is 0. So the whole thing would turn into 0. Like, but remember, this is in vertex form, so you don't have to do that whole process because you can just.
Wouldn't it be?
That one really doesn't, that does.
Okay.
Okay, hang on, I gotta turn this off.
This one does that.
Okay.
No.
So this one would be,
-5.
so we're just gonna rewrite it, negative 5 times 1/3 x to the negative 3. That is
Oh.
the same thing.
No!
So then I have y prime equals negative 5 times whatever the derivative of this one is. Well, the derivative of this is
So it's 5x.
negative 3/3 x to the negative 4. So y prime equals negative 5 times negative 1 gives us a positive 5 x to the negative 4. Okay? So that's the product and the quotient rules. Really quick, I want to show you calculator differentiation.
Are you kidding me?
So pull your calculator out, and guess what? You can do derivatives on your calculator.
Yay. I never want to do it by hand again.
Alright, they're probably easier on by hand, honestly.
A lot of them are so much easier by hand. And you can only find derivatives at a point on your calculator, okay? So,
I don't want to balance it.
okay,
It's not just gonna balance there.
Why?
so let's find the derivative of a function. So I'm going to have you go to your y equals screen, and we're going to type in a function. X to the 4th
Function.
plus 2x cubed minus 6x plus 2. So type that into your y equals screen.
6x.
Minus 6x plus 2. Now, I cannot ask this calculator to just tell me what the general derivative is, right? I can't get the derivative that gives me the equation of the tangent line, but I can say what's the derivative at a specific point. So if I want to say what's the slope of the tangent line at 2, I can say what's the derivative at 2, and it'll tell me, okay? So go ahead and quit your y equals screen until you're just back.
Second mode.
Second mode, yep. Then you're going to click math.
Derivative.
And then here at number 8 it says n derivative. So we're going to push enter. Oh gosh.
Why is mine so goofy?
Does yours look nicer than mine?
Mine looks exactly.
Oh,
the format.
what does yours look like? Like mine?
Yeah.
Okay. If yours looks nicer than
What do you
mine,
consider nicer?
it says like D something.
Okay.
Okay, yours looks way better. So this one, for the old school one, I think we have to do X,
Number 8.
comma. Okay, so for you guys that have the really nice, it looks like
Is
D
it comma?
something.
I didn't even know there
Put
was a
X
comma.
there because we're doing derivative with respect to X, right?
Mm-hmm.
Okay, and then
The comma button doesn't work.
then you have like parentheses.
Yep.
Okay, so inside your parentheses, now for those of you who have old school, we put a comma,
I can't.
and we're gonna find that function we just put in. So you're gonna push bars. You go y bars,
Where is bars?
overwrite clear, function,
Bars.
and y1. Okay, so you go to vars,
Bars.
arrow over to y bars.
Y
Bars. Y bars.
X equals.
And you said function,
Yeah, man.
What?
Okay,
and then y and y.
so yeah, you should have,
And then do I?
perfect.
Oh,
Okay, now put another comma,
Over to
and
y
if you,
bars and function.
function,
On
Oh, yeah.
and then push enter, because now we want y1, because that's the one we put in as y1, right? And then you might have x equals and a box. If you don't, you're going to put a comma. And let's find the derivative at 2.
2.
Okay.
And parentheses.
I haven't tried this old school way before, and I'm hoping. Oh! All right, we'll do it tomorrow.
I got a 50.
Yeah.
00001.
It's something to do with our commas. All right, we'll do it next. We'll do it tomorrow. My calculator at home does it nicer, and I thought I knew how to do it on this one, but it didn't turn out the way it was supposed to.